Let's get started. Good morning again. Uh, so I will summarize the important ideas that we have looked at so far and see that we are all on the same page. So the first thing is this: if you look at is a task, we have seen different tasks. The first task is you have to write a program. Okay, so write a program. This is the first task. And in order to write a program, we have to use some tool or other. And in this course, we decided to use VS Code editor. It is more than an editor, but we decided to use VS Code editor in this course. There are other editors such as Autumn, Sublime, Vim, Sea Lion, etc. Okay, so there are many other tools, but we have decided to use VS Code. And we are using this VS Code editor just to enter our program. It can do many other things, like we can compile the program within the VS Code. We can run the program within VS Code. We can debug the program. There are many things that you can do using the VS Code editor. But at this point in time, we are just using the VS Code editor to write our programs. And it provides nice syntax highlighting features, and that feature we will use at this point of time. This is the tool. And then if you see, if you go this way, so if you take this, your program is present in, let's say, pun.c is the program that we have seen, and this program is present in the hard disk. We use this notation, the small picture, to indicate that it is a hard disk. So either it is present in your hard disk or on solid state drive. Essentially, whatever HDD, SSD, don't worry about it. It is persistent storage. It stays on your file system. Your pun.c is present in your on your hard disk. And we call this as source code, or pun.c. We call it as source code or source program. Source code or program. So this is the starting point. This is the starting point. You want to write a program. You use VS Code editor to enter the program, and this program resides on your hard disk. And we call this program pun.c or hello.c or sor.c, whatever it may be. We call this as the source code or the source program. After we write the program, we would like to compile this program. Compile the program. And in order to compile the program, we use the compiler GCC. GCC is the compiler that we would like to use. There are other compilers, like for example, so those of you who are using Mac, they may have a compiler called as Clang present on their machine. But you can install GCC compiler also on your machine. And what is the command to compile your program? So GCC pun.c. If you just see GCC pun.c, the executable will be generated in the default file a.out. But you can use a different, you can specify that you would like your executable to be present in a specific file, like for example, pun. It's possible to do this. And if you see again, your executable, be it whether it is named pun or a.out, it is present on the hard disk again. It is present on the hard disk. Whether it is pun or a.out, it is present on the hard disk. And we call this as executable code or the program. Executable code / program. This is what it is. And then, so now your executable code or program is still present on the hard disk. It is not yet active. The third step is we want to execute the program. This is the third step. And when we want to execute the program, so those of you who are using Linux, usually it comes with a bash shell. So it is also called as terminal, we call. On the terminal, we give a command such as /a.out or /pun. You give the command for execution. And those of you who are working on Windows, even students who are using Mac, they still have a shell and they can still execute the programs the same way. Those of you who are using Windows environment, Windows operating system, so I suggested you may use Cygwin, and Cygwin also provides a shell, and at the shell you can give a program for execution. And what happens is when you give a program for execution, this idea I really want you to keep in mind that this is your RAM, which is a sequence of bytes. This is your RAM, or may also called as main memory. This is a sequence of bytes. Once you give your program for execution, your executable program which is present on the hard disk will be loaded into the main memory. Will be loaded into the main memory. And then once it is loaded into the main memory, your processor starts executing the instructions of your program. The CPU or processor starts executing the instructions of your program. And every program that is which is active, it becomes what is called as a process. So there will be a process associated with a program. Is a process, your program, your executable program. From your executable program, a process has been created, and this process is active, and it is and through this process, the instructions of the program are being currently executed. And every process has a process ID, PID. From the same executable program, it is possible for us to create multiple processes. For example, if you know the Chrome browser or Firefox or Internet Explorer, it is possible to have multiple Internet Explorers simultaneously active, right? But the executable that is present on the hard disk is the same, but two different Internet Explorer processes are simultaneously being active. So there is a question, is a process created when we type /a.out? Exactly, Harshit. So when you type this command, a process will be created. So my first question for all of you is, are you all with me till this point? If you understand this much, you're all good. Is there anyone who has questions at this point? So there's a question on, can you repeat the browser part? So all I'm telling you is there is one executable, just like a.out or pun, there is an executable for the Internet Explorer browser present on the hard disk. Like for example, here, if you see on my screen, the mouse is over the Mozilla Firefox web browser. And When we click on that thing, then what happens is a process associated with the Firefox uh, program will be created, and you can create one more Firefox browser using the same executable. The underlying executable name is the same, but when you execute it 2 times, each will get a different process ID. Okay. So now so there is a question on what the compiler will do. We have seen in detail what the compiler will do in the last class. And so the compiler maps your source code pun.c into a.out. That is what into an executable file. That is what the compiler does. The compiler translates the C code into a form which your processor can understand. That is, it generates the a.out file. It generates the executable file. All right. So let's move on. So yeah. So there is what is so we as the course progresses, each of you we have to develop what is called as computational thinking. So what does computational thinking involve? So the first thing is there is a problem that we would like to solve using computers. So we will learn how to do problem modeling. Okay, so the first part of computational thinking is problem modeling. As through various assignments you do in this course, you will learn this problem modeling part. All right. The second part is algorithms. These two are related with each other. So once you model a problem, in order to uh, answer certain questions associated with the problem model, we will devise algorithms. We devise algorithms. Like for example, uh, if you want to build a software which stores the rank of all JEE marks uh, and JEE entrance exam related, all the things related to JEE exams, IIT JEE exam, so there's a student ID and student has marks, ranks, etc. So there is a real world thing that is an entrance exam that is happening, and we need to model it in order to build software to do it. And once we build a model, we may want to ask questions on that model, like for example, can we get the top 100 rankers, or can we get what is the average marks in the physics exam, like that. So there algorithms come into picture. So there is problem modeling and there is algorithms. So the algorithm depend on the problem model, and the problem model also depends on what kind of, we should be able to envisage what kind of algorithms we may have to uh, build over this problem model. These two are interdependent on each other. What is an algorithm? An algorithm is it clearly tells this is step 1, step 2, this is step 3. So a clear sequence of steps, instructions which the computer can carry out. It is what is called as an algorithm. That's all. And once we have this algorithm in mind, then we would like to express this algorithm in one of the available programming languages. Like for example, you can use C, C++, no, Java, There are so many programming languages. You can use one of these programming languages to express your algorithms. But one important thing is there is what is called as an underlying execution model. And a specific execution model that we have seen is what is called as a sequential execution model. This execution model is also important. So what is the sequential execution model? The sequential execution model says there is a single thread of execution, and what this single thread does is it fetches an instruction, it decodes the fetched instruction, and it executes it. And it keeps repeating this process. Fetch, decode, execute, fetch, decode, execute. There is one thread of single thread of execution that is present. When we are building algorithms, what happens is this execution model will have an impact on the way we design the algorithms. And this execution model also will have an impact on the programming language design itself. All right, later on, for example, maybe towards the end of the course, we will see a different execution model, which is called as a multi-threaded execution model. And when we think about multi-threaded execution model, then the way we go about designing algorithms for multi-threaded execution model will be different. And the kind of language constructs that we use from C or C++ to express these algorithms which are designed keeping this multi-threaded execution model in mind, they will be different. For 90% of the class, we will just be using this sequential execution model, which is a single thread of execution, and a processor fetches certain instruction, decodes the instruction, and executes the instruction, and it keeps doing it ad infinitum. This is what it is. And if you think of this course, if we divide this course, this is a 12-week course, and we divide this course into two parts, roughly two equal parts. In the first half of the course, so if you see, there are two parts. One is computational thinking. I'm using this CT as a shorthand for computational thinking, and CP for C programming. Okay, C programming. In the first half of the course, we spend more time, 80% of the time, on C programming, trying to understand the programming language, and 20% of the time on computational thinking. And in the second half of the course, what we do is we spend more time on computational thinking and less time on programming. By the time, all of you will be very familiar with writing programs. If you have an algorithm in mind, you know how to express that algorithm in C programming language. By the time, in the next 6 weeks, in the next 5 weeks, you will get comfortable with the C programming language. And in the second half, we will focus on algorithms where we try to build this computational thinking. And this is what is going to happen for the rest of the semester. All right. Are you all with me so far? So there is a question on books. So you will get an ebook in a day or two. Okay. So the book title I have already announced, and you will get that book. We are ordering that book. By Wednesday, the book should be available to you. Great. Now let's take a look at the pun.c program we have seen in the last class. I will share my screen. Okay, are you able to see the screen? So pun.c, so this is the program that we have seen in the last class. And so this is a program, when we execute this program, it prints the string that is passed, the string literal. A string literal is passed as a parameter to the printf function. When we compile this program and execute this program, uh, the, the, the printf statement gets executed and it will be printed onto the screen. Let's see, let's do it one more time again so that, so you say gcc pun.c minus o pun. We have compiled the program and we are saying execute the program. So when we execute the program, this program has one function, main. Every C program, it should have a main function. And this main function has two statements. One is a printf statement, and printf is a library call. It's a library call, and there is a return statement. After this printf statement gets executed, the return statement gets executed. And what happens when the return statement gets executed is the control transfers back to the operating system, and the return code 0 will be returned to the operating system. This is what happens when we execute this pun.c program. All right. So one thing is here is there is something about comments. Okay, it is possible for us. So it's good. It's important that we document our code properly. So, like for example, for this code, you can say no. So the name of the author of this program is Suresh Purini. Okay, so date on which this program is written is 21st September 21st 2020. Like that, we can you can write, you should comment your program well. You should comment your program well. And there are two different styles for commenting. So like for example, one style of commenting you have seen here, but there is a different style for commenting. That is, if you say this like this, this is what is called as a C++ style of commenting, where we use two forward slashes. Program is successfully terminating and returning 0. Okay, so this is a single line comment. So there are two ways in which you can comment your code. One way of commenting is by making use of this. On line 1, you will see forward slash followed by star, and the way you end the comment is on line 3. That is, you have a star followed by forward slash. And this is if you see here, for this is another way of commenting, where we use two forward slashes, but the comment will be restricted to a single line. You cannot have a multi-line comment. So let's see, whatever that is present with commented, the compiler completely ignores it. Like gcc pun.c minus o pun, then so the program didn't change in spite of the comments. But like for example, let's say if I want to comment this printf statement, I can comment this printf statement. So now if I execute this program, nothing will be printed. Okay, because the printf statement is commented out and the compiler ignores whatever that is present. So nothing will be presented. So gcc pun.c minus o pun. dot slash. So now, since the printf statement is commented out, nothing gets executed. See, there are few questions on why a dot out is present. A dot out is from, I didn't remove the a dot out, it's from previous compilation. So now I am removing a dot out, okay? So now, a dot out is not there. I'm removing pun2. So if you see, there is only pun.c is present. So you can see gcc pun.c minus o pun, and then I will say pun, and nothing gets printed. All right. There is one thing, so which I would like to specify, mention here. So in C programming language, initially, let me share this. So if you consider the C programming language, there are three different, originally C programming language, it came from Bell Labs in US. And the way the language is described or mentioned is through this book called as the C programming language. The authors for this book are Kernighan and Ritchie. So it's not like really a proper, a formal definition of the C programming language. But the C programming, these two authors who built the C compiler, they published a book called as the C programming language by Kernighan and Ritchie. This is the classic book on C. What happened is, this happened around in 1978, but after that, what happened is there are many different people started building their own compilers, and there are many variants of C programming language started popping up. Okay, many variants of C programming language started popping up. And it becomes an issue because it is like this. So let's say I gave you a homework problem and you have written your homework problem using a compiler which supports certain features of C, and you have submitted the homework to me, and then I compile your program using my own compiler, and it's not compiling because there are some features supported by your compiler but not supported by my compiler. Okay, that will cause lot of problems. So in order to solve this problem, in around 1989, 10 years later, so there is a standards body has come together, and they have come up with a standard for the C programming language, and that is called as C89 or C90 standard. Okay, so this is the first one. This Kernighan and K and RC means Kernighan and Ritchie C, which it came out in 1978, and then in 1989, roughly 10 years later, so there is a standard called a C89 or C90, and then 10 years later, so there is another standard called a C99 that has come. So when you are reading the book, uh, the author keeps saying, no, so by and large, the core of the C remains the same. There are few things that are there in C99 which are not there in C89. An example of such a thing is the comment. Like for example, here in C89, this forward slash comment, this is not supported, but in C99, forward slash comment is supported. This is not supported here, but it is supported in C99. So when you are compiling, for example, let's go to the compiler. Let's actually go back and change the code, uncomment this code. So printf. So we have the printf here. And so if you see gcc pun.c minus so pun, there is no problem. We are able to run the code again, not an issue. All right. But remember, this forward slash comment is supported in C80, C99, but not in C89. So if, and the default by GCC by default, it uses C99 standard, but instead if you use C89 standard, pun.c, and the way we specify that we would like to use C89 standard is by using the keyword, by using this option. Minus std is equal to C18 minus pun.c minus open, and then you will see an error. Okay, C++ style comments are not allowed in ISO C90. Okay, this is the error that you are getting. But if you compile the same using C99 standard, the compilation will go successfully. Okay, are you all with me here? There are three different standards. The original K and R C, that is Kernighan and Ritchie C. It is not really a standard. It's a, they developed that language, they built a compiler for it, and then they published that language. They described that language using examples, etc., in a book which is called as the C programming language book. And then later, 10 years later, in 1989, a new standard has come up, that is C89 standard. And then again 10 years later since then, so a new standard called as C99 standard has come up. Are you all with me on this thing? K and RC, C89, C99? Good. So one more thing that you should uh, develop from day one is proper code indentation, coding style. You need to follow good coding style. The one important part of coding style, of course, is comments. Okay, so let me. So one part, so comments. Sorry. So comments is, you need to document your code properly. Comments or code documentation, so that other people can understand, not only others, so even myself, even like for example, if I write a code, if I wrote a code couple of years back and if I wanted to reuse it, change some parts of it and want to do something with it, if I don't have any comments, I would have forgotten what I did couple of years back, and it would be hard for myself only to read my own code. So one important aspect in while writing programs is writing appropriate comments or documenting your code is important. The second important part is proper code indentation. Okay, like for example, you cannot, like for example, you cannot have something like this. So I have seen many students write code like this. So you have, so here, this is not a properly indented code. So you can usually what we do is we give one tab, another tab, so that no, this code becomes properly indented. There is one more style issue. Some people use this left flower bracket. Hello. You can keep this right left floor bracket here also. This is so there are some people who want to use that left floor bracket on the same line as the function line on line 7, and there are some people who like it this way. And also it is good idea to separate, to give blank lines between two different logical sections of the code. Like for example, after line 5, you may want to give a blank line before you start main. This is a good coding style. So one good thing about this VS Code, etc., is suppose you have this code. If you see this code is not properly indented, so I have written something like this. This is a code which is not pretty. This is not a standard way of writing the code. But if you go and check, no, there is an option called as format document, which or Control Shift I. When you do that, then VS Code automatically beautifies your code. So you can use the the VS Code for documenter and the format your document option and nicely document and so that all indentation and stylistic issues are taken care of. In all the code that is being in all the code that you write in homeworks or in projects, I really want you to comment your code and properly indent your code. So when someone looks at it, they will get a broad understanding of the structure of your program. They may not immediately understand the logic. They will understand, you have these 4 functions and this particular function has these statements. So all that, when they look at the code, they should understand the structure of your program to start with. Great. So now let's look at one more. Let's keep going. So we'll look at more program features. So now we have a program called as fun.c. So here, yeah. So this is a program where we want to compute the volume of a cube. Okay, we want to measure the volume of a cube. So one thing here, this is what is called as a modeling. So you have a cube, okay, you have a cuboid, and this it has some length. It has some length. So this is, it's like, for example, in this, let's say its length is 3, and its breadth is 5, and its height is 2 centimeters. All right. And we want to compute the volume of this cuboid. One thing that, so we were thinking about computational models. So when we are thinking about, when we want to compute the volume of a cuboid, we are not really interested in, like what is the weight of the cube or what is the color of the cube, what is the surface colors of the cube, okay, what is the, yeah, what is the texture of the cube. All those things, they are not important for us if you are interested in volume. So depending upon what you are interested in about the problem at hand, you need to represent the object that we are studying appropriately in your program. This is what is called as problem modeling. Like, for example, the color of this cuboid could be something like this. But you are not interested in representing the color of the cuboid if you are interested in computing the volume of the cube, right? So it's and then you are not, again, not interested in the texture of the surface of the cuboid if you just want to compute the volume of the cube. So when you have a problem at hand, when you want to build a model for that problem, depending upon what questions you would like to answer, you want to build an appropriate model. But on the contrary, let's say if you are building a game in which then the color of the cuboid becomes important. And maybe the texture also becomes important, because if some player in the game is climbing the cuboid, and if the texture is slippery, he may fall, he may have to go slow, things like that, in which case those parameters also become important. Great. So here, next thing here is, so in this, we want to capture, so now we are working with a cube whose dimensions are fixed. That is, it has length. So if you see here, its length is 3 centimeters and breadth is 5 centimeters and height is 2 centimeters. All right. So we want to capture the length, breadth, and height. So we use what are called as program variables in order to store the length, breadth, and height of this cube. And so on line number 6, you see, and on line number 6 and line number 7, you see what are called as variable declarations. You see, these are called as variable declarations. So you have on line 6 and 7, you have variable declarations. Followed by that, you have a sequence of program statements. From lines 9 to 18, you have program statements available. So line 6 to 7, you have variable declarations. And from line 9 to line 18, you have program statements. And variable declarations, they provide information to the compiler. They provide information to the compiler that I want to use these variables in my program. And now let's see on line number 9 what happens. Okay. So on line number 9, we have what is called as an assignment statement where we are assigning this integer value 3 to the variable length. So what happens is when you declare a variable, what the compiler does is the compiler sets up memory. It allocates memory for these variables in the RAM. Like for example, this could be the memory associated for the variable length. And initially on when you start the program, if you go see on line number 8, the value that is present in the length variable, this is your RAM, the value that is present in the memory associated with the length variable, it is garbage. On line number 8, if you see, it's a length is an uninitialized variable. So all these variables, they are uninitialized. So the value that they hold can be arbitrary values. You don't know what they are. But after line number 9, at line number 9, what happens is when you say length is equal to 3, the integer value 3, it will be assigned to the memory location associated with length. And the memory location associated for breadth could be something like this. So breadth is allocated memory here. So after line number 10 gets executed, what happens is this memory location takes the value 5. And let's say this is the memory location associated with the height. And after line number 11 gets executed, height gets the value 2. So after the state of the program, the state of the memory after lines 9, 10, and 11 gets executed, it will be like this. The length, the memory location associated with length, it will contain 3, and the memory location associated with the breadth, it will be 5, and the memory location associated with height, it will contain 2. So as the program gets executed, what happens is the state of the program keeps evolving. Okay, the state of the program keeps evolving. So let's say, let's say this is some state of the program, and if some statement gets executed, the program evolves to a new state. Okay, so on and so forth. As the statements in the program keeps executing, the state of the program, it keeps evolving. Right? And then if you see line number 13, in line number 13 is where we are doing a computation. Volume is equal to length times. So this operator star, it is what is called as a multiplication operator. Okay, so you are doing multiplication. Okay, so volume is equal to length times breadth times height. And then finally on line number 15, we are printing the dimensions of the cube. We are using a printf statement to print the dimensions of the cube. And what is important here is the %d that is present here, it is associated, if you see, to this, the printf statement, the first parameter, it is a string, it's a string literal. This whole thing that is present from here to here, this is a string literal. And the %d and this string literal, wherever the characters are there, they will be printed automatically. But when something starts with %, then that means it's what is called as a placeholder. So this %d, which is the first %d occurring in this format specifier, which is occurring in this string, it will be associated with this variable length. So whatever the value of length, it will be printed uh, in its place. Okay, and x is just a character, and then again the next %d, it is associated with this breadth. All right. Similarly, there is a height. Let me clear all my drawings. Yeah. So if you see, and then you have height, this height is associated with this %d. And so on line number 15, we print the dimensions of the cube. And then on line number 16, we print the volume of the cube. Okay, let's run this program and see what happens. So GCC cube1.c. And so I didn't use any -o option. So the executable will be generated in in a.out. So I'm executing this. So it says the dimensions of the cube are 3 by 5 by 2, and the volume is 30. So if you're not happy that I need a space between 3 space times space 5 space etc., then all you have to do is you go to %d, after that give a space, after x give a space, after %d give a space here, and this is how we can. So now let's compile this program and see how it will be. GCC cube1.c, and if you run it, so now it says this is the cube dimensions, and the volume is 30. Are you all with me here so far?
Sir, one question, sir.
Yes.
So the percentage D, the placeholder you told us about, so it just reserves a memory location for the variable?
No, it doesn't reserve any memory location for the variable. It just tells you how to print it. It's not like a placeholder for printing, not for storing. It's not for storing. It's a format specifier, as Varshita mentioned.
So
It
it's
tells
just
us,
used to show the order.
sorry?
So it's just used to show the order of
Yeah,
printing.
that's true. The first %d corresponds to the first, no, the length, and the second %d corresponds to the breadth, and the third %d corresponds to the height. So wherever the third %d is there, no, so whatever the value of height, it will be printed there.
Thank you, sir.
All right.
Sir,
Yes.
I have a
Please
doubt, sir.
introduce yourselves and.
Huh? Sir, you didn't include void in that main, and I read that we use void to indicate there is no arguments, but here, like if we use void, then the output should remain same, right?
Yeah, that's true. Uh, that whether you use void or you leave it empty, when you leave it empty for that, now the parameters for main, it is assumed to be void.
Okay, sir.
It's not an issue.
Okay, thank you.
All right. So now let's say if you want to compute the perimeter of this cube, then what we can do is, for example, so now we can say int perimeter. Int stands for the memory that is associated, the value that you are holding in the variable length, breadth, height, they are all int. That keyword, int, is what is called as a keyword. It is what is called as a type specifier. Int is a keyword. It's a keyword type specifier. It tells that these variables, they are of type, they hold values or objects which are of type integer. Let's say if you want to compute perimeter, then what we can do is printf perimeter of the cube is, so here we don't know what is the perimeter of the cube to put it in this string. So we have this format specifier or placeholder, and then what is the perimeter of the string of it is 4 times length length plus. So if this all looks too much to you, you can do one thing. So the perimeter of the string is 4 times length plus breadth plus height, and then you want to print the perimeter here. Okay. So now let's compile this program. So GCC cube1.c. Now you'll see the perimeter of the cube is 40. All right. So here one question is there. You can see there are variable declarations here. So there are variable declarations here, and there is a variable declaration here also. And this kind of interspersing variable declarations with statements, this is permitted only in C99 standard. Okay, like for example, if you compile this program using std C89, it is permitting. I thought this is not supposed to in so in earlier versions of C, it seems even in C89, the declarations in the middle of programs, in the middle of the statements is permitted. But in the first version of C that came, that is in K and RC, definitely this perimeter, it cannot be there. You have to declare this perimeter here. Okay, you have to declare this perimeter here. So GCC cube1.c /a. So a couple of more points here is on line number 19. So on line number 21, instead of computing perimeter, we can do one thing. So we can eliminate this statement. No, on line number 19, we don't want to use an extra variable, and we can just use an expression here. And then on this 8 also we don't need, because we no longer need the perimeter variable. So in printf, we are here we are passing an expression as a parameter. If you look this printf has 2 parameters. One parameter is this whole string literal, and other parameter is this whole expression. Okay, the whole expression will be computed, and whatever the value that will be printed at the position where %d is specified. Let's compile this program and see it runs. Okay, so if you see, it still works. So here what we did, we used the expression directly in line number 21. One more modification we can do in this particular case is we can say equal to 3, breadth equal to 5, height equal to 2, and so here we are initializing at the time of declaration itself, and we are commenting this out, and gcc cube 1.c, it still works. Okay, so we are initializing these variables at the time of declaration itself. The most important thing that you need to understand though is each of these variables, they are allocated memory. And when you do these assignments, these values will go and sit in the memory, and that's what happens. There is one more interesting thing is you are saying that no, the volume of the cube is 3 centimeters by 5 centimeters by 2 centimeters. The computer doesn't know, no, when you say the length is equal to 3, whether it is 3 centimeters, or breadth is equal to 5, whether it is 5 centimeters or 5 meters. The computer doesn't know. But in your mental model, you know that this 3 corresponds to 3 centimeters and this 5 corresponds to this 5 centimeters, so on and so forth. In your mental model, you know the units for these values that you are assigning to these different variables. And the computer doesn't have any clue about it.
So,
Yeah,
so in line number 21,
yeah.
are there 3% is required or only one is fine for
Or,
different length, for length, breadth, and height?
yeah.
Aren't 3% is required?
No, no, it is only one, because if you see the whole of this, it returns a value. This is an expression. This is what is called as an expression. This expression will be computed. So length, what is the value of length? The value of length is 3. At this point, the value of breadth is 5. The value of height is 2. So what happens is this whole expression will be computed, and there is only one value that comes out, and that will be printed.
Okay, thank you, sir.
Sir, Lakshmanan here.
Yes.
I had a doubt. So if C99 can compile all the C89 and C90 codes,
No,
what's
no,
the
no. No, no, you cannot compile. Oh, yeah, maybe that's true. If you use C99, maybe, okay.
because there's only restrictions that are placed in
That's
C89 and C90, right?
okay.
So
Okay.
then what's the use of having old standards now, like C89 and C90, when C99 already does all that and more?
No, just because it's legacy code, you want, someone may have written code 30 years back, and you still want no, that code to be, you should be able to compile that code.
Yeah, but can't C99 compile that as well?
Can't C99 compile that? Good question. So you mean you don't want, why the necessity for
Yeah.
C89? No?
Yeah, exactly, sir.
Good question. Good question. I don't have an answer for it immediately, because C99 should be able to handle C89 standard also. Uh, Let me think. It's a good question. I will think and get back to you, Lakshman.
Sure, sir. Thank you, sir.
So I'll conclude today's lecture here. So what we will do is tomorrow in the lab session from 2:30 to 3:30, I will take, we missed one lecture. I would like to take a makeup class. So what we will do is 2:30 to 3:30 tomorrow, we will continue this lecture. And so from 3:30 to 5:30, you will have the lab session. That is the plan for tomorrow. For the lab tomorrow, 2:30 to 5:30 is your lab session. 2:30 to 3:30, you will all be together. And I will take the makeup class. We will look at a couple of more code examples. And after that, we will release the first problem set. Okay. So questions, so should I stop recording or should I continue recording if we have questions? Maybe let me continue recording. Yeah. Okay, any questions? So if that is all, so that's all for today. And I hope all of you are with me. And
Sir?
just want to see, so you're all doing good today. How is today's lecture? Are you with me throughout the lecture? Good. So we will take we'll have maintained the same pace, and I want everyone to be on board. And uh, yeah, so that's
Sir,
yeah,
I have a doubt.
please go ahead. Yeah.
Last class, in the assignment, you gave a question to execute CPP,
Right.
pun.c, angular bracket pun.I.
Yeah.
It's not working on my system. It gives a really long error. Uh, I tried
What did you do? CPP 1.c.
angular bracket pun.I to redirect the file.
Okay, okay. What happened?
And it gives a really long error, sir. Would you know the reason why? I consulted a senior as well. He didn't know. He didn't know why exactly that was happening. I'm using a Mac OS, if that helps.
Oh, Mac. Okay.
I tried it on my Linux VM as well, and the same error was happening.
Mhm. Not sure. I have to see why it should not happen. I don't know the reason. So, what error do you see? The error? Can you tell me the error?
Okay, sir. May I send it to you via mail because it's really
Yeah,
long?
sure. Definitely, I will do. That will good. That's good.
All right. Thank you, sir.
Good morning, sir.
Good morning.
Um, Sir, this is Amay speaking. Sir, I had a lot of trouble getting into class today. Sir, I tried the link that was previously sent on mail via Zoom. Then it wasn't working, and I also checked my team, so it wasn't working either. So till 10th, after 10:30, I had no clue if any classes were going on because I had checked Zoom and Teams both, and both weren't working. I used my password